This lesson is all about graphing absolute value functions. So what we're going to start with is what does an absolute value function actually look like? So to begin that, what we're going to do is make a table of values for this function f of x equaling the absolute value of x. So I'm going to plug in -1, 0, and 1 into that function. So if I plug in -1, the absolute value of -1 is 1. Absolute value of 0 is 0. And the absolute value of 1 is 1. Now over on the graph, we're going to graph each of those points. So -1, 1 is right here. 0, 0 is at the origin. And 1, 1 is right here. So what ends up happening is we get a V shape. And an absolute value graph is always a V shape. So this is the absolute value of x. Now what we're going to do is graph these other two functions. And the other two functions are slightly different. We're taking the absolute value of x, but then we're adding 2. I'm going to do the same points, -1, 0, and 1. So if I do the absolute value of -1 plus 2, I get 1 plus 2, which is 3. If I plug in 0, the absolute value of 0 plus 2 is 2. And the absolute value of 1 plus 2 is 3. So I'm going to graph this on the same coordinate plane. So I go -1, 3 is my first point, 0, 2 is my second point, and 1, 3 is my third point. So if I go ahead and graph that, let's take a look at what happened. Notice that from the original graph, every point got shifted up 2 units. And that's where the plus 2 comes from. So without making a table, what we're going to do is we're going to graph this last function. And it's the absolute value of x subtract 3. So if the red graph got shifted up 2 units from the previous one, this one should shift the graph down 3 units. So this is the absolute value of x minus 3. Okay. All right. I'm going to graph the original function, the absolute value of x, which always starts at 0, 0. And now we're going to do a different kind of absolute value. This time, inside the absolute values, we have a subtract 4. What happens when we subtract 4 inside the absolute values? So what we're going to do is we're going to start with making a table of values like we did before. This time I'm going to do like -1, 0, 1, 2, 3, 4, and 5. So we're going to plug those in. The absolute value of -1 minus 4 is the absolute value of -5, so we get 5. Now we're going to plug in 0. The absolute value of 0 minus 4 is the absolute value of -4, which is 4. We plug in 1. Absolute value of 1 minus 4 is the absolute value of -3, which is 3. And we're going to continue this process. The absolute value of 2 minus 4 is -2, so we get 2. Absolute value of 3 minus 4 is -1. Absolute value is 1. Absolute value of 4 minus 4 is 0. And the absolute value of 5 minus 4 is 1. And then we're going to graph those points. So we have -1, 5, 0, 4, 1, 3, 2, 2, 3, 1, 4, 0, and 5, 1. Now if I were to continue, I would continue to get dots like this. So now I want you to take a look at this graph. So if the white one is the absolute value of x, and this one is the absolute value of x minus 4, what kind of shift do you see with the graph? Well, notice that it moved to the right 4. So if we take that information, how do you expect the absolute value of x plus 2 to shift? If a minus 4, subtract 4 went to the right, a plus 2 inside the absolute value should move it to the left. So if we take each of the points from the original, normally they start right here at 0, 0, and shift it over to, the absolute value is going to land right here. So this is called a horizontal shift. Now we're going to tack on a negative. So again, let's start with our absolute value of x. This is called the parent function. It's the normal one. And then what we're going to do is we're going to apply a negative outside. So we're going to do negative 1, 0, and 1. The negative absolute value of negative 1. The absolute value of negative 1 is 1, and we have a negative, so it's negative 1. Absolute value of 0 with a negative is still 0. Negative absolute value of 1 is negative 1. So I'm going to graph that one in the coordinate plane. So we have negative 1, 0, 0, and 1, 0. So what happens when we tack a negative on the front of the absolute value? Well, it flips the graph over, and we call that a reflection. Okay? All right, so what does a number in front of the absolute value do? Well, here's our normal function, the absolute value of x. And now we're going to plug a 3 in front of it. So we're going to plug in negative 0, 1, and 1. 3 times the absolute value of negative 1 is 3 times 1, which is 3. 3 times the absolute value of 0 is 3 times 0, which is 0. And 3 times the absolute value of 1 is 3 times 1, which is 3. Alright, so let's graph that one in blue. So negative 1, 3 is our first point, 0, 0 is our second point, and 1, 3 is our first point. So now, this graph still starts at 0, 0, but it's much narrower, and we call that a stretch. So a number in front, if it's greater than 1, is a stretch. So what do you think a number between 0 and 1 is going to do to a graph? Well, I'm going to make a table again of negative 1, 0, and 1. So 1/2 times the absolute value of negative 1 is 1/2 times 1, which is 1/2. If I plug in 0, 1/2 times the absolute value of 0 is 0, and 1/2 times the absolute value of 1 is 1/2. And I'm going to graph this one in red. So negative 1, 1/2. 0, 0, 1, 1/2. So what ends up happening is if this value in front of the absolute value is between 0 and 1, we get what's called a compression. And the graph is spread wider. Okay, so we're going to generalize now. We have a few things that are happening. A value in front of the graph is a compression or a stretch. A value that's inside the absolute value with the x is a horizontal shift. And you need to think opposite. And we'll talk about that in just a moment. And then the number that's outside the absolute value is a vertical shift. Okay, so what does it look like to graph something like this? Well, right here, a negative or a positive 1 moves this graph to the left. And a negative 3 moves this graph down. So that vertex of our graph, the point where it changes, this right here is called the vertex, is going to be -1, -3. So that's an ordered pair. We get -1, -3. So this graph is going to be shifted -1 down 3. So that's where the graph's going to start. This -2 tells us it's going to be reflected, or upside down, and the 2 tells us the slope. So what we're going to do is, once we know our vertex, which comes from the left or right and up or down, we're going to use the slope of -2, and we're going to count from this vertex. So it's going to go down 2 over 1. So that's going to be 1/2 of our v. Well, the other half of the v is going to be a mirror image to the other side, and that's how we graph it. All right, let's do one more example. So let's let our equation be 3 times the absolute value of x minus 1 plus 2. So the first thing we're going to do is find that vertex, which is where this graph shifts. This part right here, this -1, tells us we're going to go right 1, which means it's going to be a positive 1 because it's right 1. This is our vertical shift, so it's going to go up 2, so we're going to have a positive 2, and that's where our vertex is going to be. So on my graph, I'm going to start with graphing the vertex of this absolute value. So 1, 2 is right here. And then we're going to deal with the slope, and the slope is 3. So from this point I started with, I'm going to count up 3 over 1 to get the first half of my absolute value. Now since this is symmetrical, the other half of our v is to the left. And that's how you graph an absolute value equation.